Namaste. This is Pushpavati SM, Assistant Professor, Department of Mechanical Engineering, Government Engineering College, KRPete. And today I'll be talking something about Design of Machine Elements 1, prescribed by VTU for 5th semester of students. Subject code is 18ME 52. In the previous two sessions, we discussed about permanent joints, that is lap joints as well as riveted joints and all. Lap and butt under the riveted joints. Different terminologies used. What is riveting? Different terms like pitch, PD, PT and all. So we discussed in the yesterday's class like caulking, fullering, why these two operations have been done. So here this sessions we will be discussing something about the failure of riveted joints. Inverse joint has been done, definitely, so we should think in a negative that this may fail, this joint may fail. Yes, of course, there are different modes of failure of riveted joints we will discuss today. Shearing and crushing of riveted joints, different types of failures. It is shearing type, crushing type, tearing of the plates, margin and along the row. So different types of failures, all this. Efficiency of the riveted joints, design of boiler joints, assumptions of boiler joints, and design of longitudinal butt for a boiler. Okay. Modes of failure of riveted joints. Okay, so rivet joint may fail in one or more types. This particular sketch is showing you about tearing of plate at the edge. You can see this edge here. Okay, concentrate on this edge line, and this the hole is showing the riveted hole actually. The two plates here. There are two plates. Riveting has been done, and this is exactly at the end. You can see tearing of the plate at the edge. This is the edge problem. Okay, so figure is showing the failure due to the tearing of the plate at the edge. Such a failure occurs due to the insufficient margin. See the distance between these two. I'm telling you about distance between this end to the the hole. This particular tearing of the plate at the edge happens because of the insufficient margin. This type of failure can be avoided by using the standard where the diameter of D is the diameter of the rivet, where D is the diameter of the rivet here. So we have to use the standard margin. Margin M should be standardized. In the different terms used in the previous session, I was talking about the margin. We should use the standard margin. If I use the standard margin, actually margin M is equal to some formula we used in the previous session actually. So if I use the standard dimension, standard margin here, we can avoid this type of tearing of plates. This is one type of failure. Next one, this is tearing and this is shearing of rivets. So if the diameter of the rivet is smaller than the necessary standard diameter, then shearing of rivets may occur. The diameter of the rivet is smaller. You can see here. Diameter of the rivet is smaller than the necessary standard diameter. So we all know that rivets are going to be inserted between the previously drilled hole on a plate. So this is a previously drilled hole, and here these two are the plate number 1, plate number 2, previously drilled hole on the plates. So this rivet should be inserted properly into the this previously drilled hole. That is a standard diameter. So if this diameter of the rivet is smaller than the standard dia, again the shearing is going to happen. Shearing is, see, now either side the force has been applied, the axial forces, the force left hand side and force on the right hand side called as axial forces. Then the rivet head itself is going to failure. This is called as shearing type of rivet. The single strap butt joint, you can see single strap, they are used. Single strap means this is the cover plate. Cover plate is called as a strap. Single strap butt joint. This is here also. If I apply the forces actually, here also the joint is going to fail because of the insufficient diameter of the rivets, we can say. Okay, so tearing type, shearing type, two types finished. Next one is crushing of the rivet plates or the rivet holes. Particular sketch is showing you the crushing. When the joint is loaded, compressive stresses induced over the contact area between the rivet and the rivet plate. So between the rivet and the rivet plate, if there are compressive type of stresses, so then the crushing of the rivets are going to become in oval shape. The particular diameter hole is there, this will become oval shape. Hence, the joint is going to lose its strength and failure may going to happen in this type of crushing. Next comes the tearing of plate across the row of the rivets. This is the row of the rivet. row number 1, row number 2, this is the rows. Along the row itself it is going to fail because here the gap between two holes is less. In this type of failure will occur very close to each other. Say this rivets, rivet number 1, rivet number 2, you can say this is a row, rivet number 1 in this and rivet number 2 in this particular row. So as the distance between these two rivets is very small, then the plate is going to collapse, the failure is going to happen. We can avoid this by using standard pitch. Pitch is one of the terminologies used in butt joints. That is the distance between two holes is called as pitch. The main plate or the cover plate may tear off across the rows of the rivet, is called as tearing of the plate across the row. These are the different four methods of failure in case of riveted joints. So we should avoid the failure by keeping proper margin, proper diameter, proper distance between two holes and all. So we can avoid the failure. Efficiency of a riveted joint. It's actually one of the ratio. Efficiency is a ratio always. Efficiency of a riveted joint is defined as the ratio of minimum strength of the joint to the strength of the solid plate. Minimum strength of the joint to the strength of the solid plate. A well-designed joint should have the same efficiency in regard to every possibility of the failure. The failure possibilities I told you, the four different failure possibilities. So, but the riveted joint should be such well designed that its efficiency in regard to every possible type of failure, it should show the efficiency. In practice, no joint is equally strong. Either the lap, butt joint may have different straps, upper cover plate, lower cover plate. It could be anything, but all type of joints will not be having equal strength in the possible. Of course, there will be tend to failures also. Tearing efficiency, shearing efficiency, crushing efficiency are the different type of efficiencies we can say. Among all the three, the lowest efficiency is taken as the efficiency of the joint. So efficiency is basically the ratio of minimum strength of the joint, the least strength of the joint to the strength of the solid plate. This is about efficiency. So after defining all these things, the failures, the different terms, the different proportions of dimension, the efficiency, butt joint, lap joint, caulking, fullering. These are the different type of operations and the different terminologies, fails and all. After discussing all this, so we are shifting into the design of boiler joints. Design of boiler joints, especially the mechanical engineering, thermal engineering, the boilers are used in thermal power plants and all. So we are going to design the boiler joints. So in the boiler, we have both circumferential rivets, circumferential riveted joint, as well as longitudinal type of joints, circumferential and longitudinal. So before going to the design of boilers, we have so many assumptions made. So from the previous sessions, from the first session, keep telling you design is a lot of assumptions. Especially the longitudinal joints are butt joints. The longitudinal joints are going to be butt joints, and circumferential joints are going to be the lap joint. Basically, it is like this. These are butted and these are lapped. So a boiler is a longitudinal joint as well as a circumferential. It is having both. It's having both. So for this purpose, the butt joint will have two cover plates used. The circumferential joint is used to get the required length of the boiler. For this purpose, a lap joint is used. Circumferential joints are lapped and the longitudinal joints are butted with different type of cover plates. Two or more cover plates to make the joint more stronger. We are going to use more number of cover plates. Longitudinal rivets will be butted, circumferential will be lapped. Okay. So assumptions. Moving on to the assumptions. So the load on the joint is equally shared by all the rivets. Load on the joints are equally shared by all the rivets. I told many times. See, this particular stage is showing many rivets, right? Horizontally, vertically, mean to say the longitudinal circumference, many rivets. So load is carried by all the rivets, equally shared by all. This is one of the assumptions made, equally shared by all the rivets. The tensile stress is equally distributed over all the section. Shearing stress and all, it's also uniform. Crushing is uniform. We say tensile stress is uniform, shear stress is uniform, crushing is also uniform. There is no bending stresses in the rivets. There is no bending, only there is a shear, crushing, like that. The whole in which the rivets are driven do not weaken the member. It's one of the assumptions, because the joint is made and even we are improving the strength of the joint also, and we have assumed that the holes because the rivet will be riveting is done on a previously drilled hole on a plate. So whatever the holes already we have drilled should not weaken the original member. That is one of the assumption made. This is one of the assumption made. Okay, the rivet fills the hole after it is driven. So rivets are the rivets are going to fill the hole, as well as they are going to join. They are going to make assembly also. They are going to join, and even the butted joints are also strong. I said the strength will be increased. The leakage, all those things can be covered by using this caulking and fullering operations also. Like we are making the rivet head down by hitting it. But there are different types. I told different type of tools we are using there. So we are going to hit it by using different type of caulking and fullering tools, and making the joints leak proof. Okay, these are different assumptions made to design a boiler joint. In general, longitudinal joints are butt, circumferential or lap and butt. I told you this. Okay, design of longitudinal butt joint. Design of longitudinal butt joint for a boiler. According to Indian standards, Indian boiler regulations, IBR, Indian boiler regulations. So this is a procedure used to the design the longitudinal butt. So we need to select the material. So design now we have to go with the design data handbooks. Especially I am going to use design data handbook by Lingaya sir. So select the type of joint we have selected is butt. So you can see these tables for the different diameters and all. Okay, next, thickness of the plate. Again, it is a standard thickness of the plate. You can go with this 13.1 equation. So this is a table and this is an equation. So always keep design data handbook with you when we start with the designs, when you start with the numericals and all. Okay. Next slide says this is the design steps. Totally there are 8 to 10 steps to design a longitudinal butt joint. 2 steps. Selection is from the table, type of joint. Next, the thickness of the plate. Diameter 13.5 C. Go to the equation number, this one in the design data handbook. So this particular formula in this the equation is unmeans empirical formula. We say diameter is given. So here if the diameter is equal to 6, when the thickness is greater than 8. If the thickness is greater than 8, diameter you can fix it as 6. If the thickness of the plate is less than 8 mm, greater than and less than, the diameter of the rivet hole is calculated by using this equation, equating to this shearing resistance to the crushing resistance. PS is equal to PC if the condition is that the thickness of the plate is less than 8. If it is greater than 8, D is equal to 6 is well and good. Then after doing all those things, go with the standard diameter. Again go with the table number. Refer design data handbook Lingaya. Okay, next procedure, like fourth step is pitch diameter. Get the equation from the design data handbook. Go through this. Equate the inputs whatever you have and get the pitch of the rivets. Pitch P. So use this PT and PS, that is tearing resistance PT and the shearing resistance as PS. Next comes the margin M is generally followed by 1.5 of the D. So to standardize the diameters, to standardize the margin and all, you can go with the table 13.1 for design data handbook Lingaya. Next, transverse pitch. Go with the table. Thickness of the cover plate here, you can go with the equation. 13.13 is the equation. 13.17 till there are 4 equations. 13.13 to 13.17, 4 equations for different cases. We need to study cover plates. For different cover plates, all the equations are available in design data handbook. You have all the inputs T, D, P and all the inputs will be having based on the problem given. Actually, I am explaining about the design procedure. When you solve some 2-3 numericals on this, you will be able to understand better. But keep design data handbook and the calculators together to solve the numericals. The length of the shank, go with this. Strength of the solid plate, then least strength. So the least strength is now calculated based on the inputs given, and the actual strength is the minimum among the 3 strengths. So 3 strengths, strength of the solid plate, there are tensile strength on the solid plate, tensile, compressive, there is a type of 3 different strengths are calculated. Then the actual strength is the minimum among all the 3 different strengths. When solving the problems, you will be able to understand these things much better after the solutions. See, these are the selection, next thickness, diameter, pitch, margin, transverse pitch, cover plate, length, strength, least strength, and all these things, all this till this. Finally, the efficiency need to be calculated. So I told you the different type of efficiency just now we discussed. Efficiency, how we are going to define is given once again here. Then the efficiency range will be given. Range is taken out from the table isn't at hand. Finally, the efficiency is written. Thus, the design of this longitudinal joint, butt joint is finished out of this 10 different procedures. Procedures need to be followed while solving the problem. Then the design of longitudinal butt joint for a boiler will be done. So how we are going to conclude this? Finally, the calculated efficiency is less than the required value. The increase the pitch of diameter or of the rivet or change the arrangement of the rivets. If the calculated efficiency is very much less than the required value, calculation is very less but requirement is more, then what we are going to do? Again, we need to increase our design. We have to improve our design. To improve our design, increase the pitch or the diameter of the rivet, or we can go with the change of the arrangement of rivets. Arrangement of rivets I have given you, different type of riveting I have given you. So arrangement also need to be changed if you want to improve the efficiency to the required level. So thus this is the actual procedure to design the longitudinal joints. Okay. So next numericals will be discussed in the next sessions. Thank you so much.